Hey there, it's Shannon MATHCHICK Myers, and today we're looking at part 2 of our trig substitution segment, which involves using our tangent theta substitution. All right, so remember that if you have not yet watched the warm-up video, you should do so because I've shown you where these substitutions come from in the warm-up. I'll put a link in the description. If the integrand has a square root of x squared plus a squared, or square root of u squared plus a squared, where u is a function of x or whatever variable you're using, and no basic integration rules, integration by parts, or regular trigonometric integral techniques work out, we can use the substitution x equals a tangent theta or u equals a tangent theta. So if we take a look at this one, what I see is that if the x had been in the numerator, the first x had been in the numerator, we would have been golden, right? We would have been able to go ahead and use just a pattern recognition or use substitution and the power rule, but it didn't happen like that. So I see that we've got a square root of a u squared plus a squared situation. So a squared is 1, and so our a is just going to be 1. We have u squared equals 9x squared, and so u is 3x. Cool so far? Now, du will be equal to 3 dx. So we're making an initial change in our integral. So our integral we'll rewrite as the integral of, we're going to need to balance out this integral because we need a 3 dx to get our du. So we'll multiply that integral by a third. So we'll have 1/3 times the integral of, I'm just going to put du in the numerator, you can do that. So du over, stopped because we have an x, but we need to be in terms of u, and u is equal to 3x. Are we good? So if I take a look here at this, an isolated x, I would have x is equal to u over 3. All right, so I'll write that in the green, u over 3. And then, continuing, we'll have to do a little more work, right? Or no, we would have u over 3, my bad, and then times the square root of u squared plus 1, which is 1 squared. Cool so far? Now the 3 in the denominator of that first u will make that coefficient to be 1. And then we'll end up with du over u times the square root of u squared plus 1 squared. Excellent. This was our initial u substitution, and now we're going to do a trig substitution. So our trig sub comes next. So u equals a, which is 1, tangent theta. So we needed du equal to, good, secant squared theta d theta And then isolating tangent theta so we can make our triangle, we're going to have tangent theta is u over 1. And then just in case we need theta alone, theta is going to be the arc tangent at u. Cool so far? Now, making our triangle, we'll have theta, and then we have tangent theta is u, side opposite, over 1, side adjacent, and then we'll have the square root of u squared plus 1 squared, which is u squared plus 1 under that radical. Good so far? Now let's check out that square root. So we are looking at a squared plus u squared. So 1 squared plus 1 squared tangent squared theta is equal to the square root of 1 plus tangent squared theta, which is just the square root of secant squared theta. That's nice. Which is secant theta. Good so far? Awesome sauce. Now back to our integral. Let's do this thing. We will have our du was secant squared theta, d theta, right? And that's over u was tangent theta, and the square root of a squared plus u squared was just secant theta. So this is how everything was matching up. We had our a squared plus u squared situation, or u squared plus a squared, however you want to say it. This guy here was equal to secant theta. Our u was secant squared theta d theta, and then our u was just tangent theta. Okay, so now let's simplify this. We're going to end up with the integral, sorry that's a little shaky, of, first of all, we'll divide out one factor of secant theta on the top and then the entire factor of secant theta on the bottom. We'll be left with 1 over cosine theta, that's what secant theta is, correct? Times, we have cotangent theta, right? 1 over tangent theta is cotangent theta, which is cosine theta over sine theta, and we still have our d theta. So these cosine thetas divide out completely now, and we're left with the integral of cosecant theta d theta, because 1 over sine theta is cosecant theta. Cool, cool? All right, so it's really important for you to know your basic trig, not trig, but any of them, the basic antiderivative formulas, because this is a basic antiderivative formula. It's negative natural log cosecant theta plus cotangent theta. Good so far? And we have plus our constant of integration. And then this will be negative natural log absolute. So cosecant theta will be the hypotenuse over side opposite, which is the square root of u squared plus 1 over u, and then the cotangent will be the side adjacent over the side opposite plus our constant. Now we already have a common denominator of u, so we'll have negative natural log I'm going to write it as 1 plus the square root of u squared plus 1 all over u plus c. Now, that's going to flip because of the negative in front of the square root. So that's like bringing that into the negative 1. So you'll have natural log absolute u over 1 plus the square root of u squared plus 1 plus our constant of integration, and then back substituting in for our original substitution here, u was equal to 3x. That's from up here. So plugging in, we will have natural log absolute 3x over 1 plus the square root of 9x squared, that's 3x the quantity squared, plus 1 plus our constant of integration. Cool, cool? Excellent. All right. And so that is our example of how to use an A tangent theta substitution. I hope you have a wonderful morning, afternoon, or evening whenever you're watching this show. If you like what I'm doing, please hit that subscribe button, like the video, share the video, and be sure to watch the next section or the next part of trig substitution, which will go over the A secant theta substitution. Bye.